Hi, everyone. Thanks for joining. I'm Annie Chang, chair of the ACES project, and along with vice chairs Rod Bogart and Joachim Zell, we welcome you to our first webinar, Integrating and Using ACES 1.2. ACES 1.2 is an important step in the development of ACES as it solidifies the specs for two key building components, namely ACES metadata file, or AMF, and the Common LUT file, or CLF. These components begin to enable ACES interoperability between products and throughout the entire color management workflow chain. And you'll see some of that demonstrated today. ACES is a community-driven project, and we appreciate you joining us today and thank everyone that has contributed to the development process and to today's event. I'm going to turn this over now to Jay-Z to walk you through today's program. Jay-Z?
Thank you, Annie. Then I want to start with Hello World, since this is a global event now going to a webinar. Last year at NAB 2019, we introduced ACES 1.1. Now we are on ACES 1.2. Rod Bogart, who was mentioned already by Annie, our partner, is actually chairing the architectural group, while I'm chairing the ACES implementation technical advisor group. What we do now is actually splitting it up into these two groups. That's new for ACES. And this year we can confirm that it works to work with an architectural and later with an implementation group. This was actually missing in previous ACES versions, so we have more security of operation out there. What is ACES? For those who are dialing in the first time or early on, the Academy Color encoding system is actually this global standard which helps us to integrate files and get matching results all around the world. Why use ACES? So we have this IDTs to get all cameras mapped into the common color space. We have the ODTs to then map or match imagery on different color spaces following industry standards for different displays. Today we want to focus on two new features which are in ACES 1.2, just recently got released. So I'm really amazed that we already have first users who can show and interact ACES 1.2 features. We start with the AMF file, and I want to hand over the word to Chris, who was the leader of the architectural group for the AMF file.
Thanks, Jay-Z. Let me get control here. All right. Hello, everyone. Good to see everyone joined here virtually. My name is Chris Clark. I am manager of imaging technology at Netflix, and I was the working group chair for AMF on the architecture side. So we were the group that was working on the specification for AMF. So let's talk about it. So as you might have guessed, AMF is a metadata standard. And one question that often comes up when I talk about AMF is, why do we need metadata for ACES? I thought it was this magical thing that solved all my color problems. Why would I need a metadata file? So let's talk through some scenarios that we hear commonly, even in ACES workflows today, that we think metadata could help with. So a colorist might say, I'm starting an ACES project and I want to build a look. How do I create that? How do I store it and share it? So for those of you familiar with ACES, know that there's this concept of an LMT, a look modification transform. And so one of the key features of AMF is to contain those looks and be able to share them and store them with other people. Another one is a studio or a production company might say, well, I'm finishing an ACES project and I want to archive it. How do I store what was actually used? And things like ACES version, output transforms, those are really important components to be able to archive along with the images in order to be able to pull it off the shelf later. And my favorite one, even on ACES projects, I still have these confusing emails, specs, and crazy .cube file names to figure out the color pipeline. So One of the analogies I like to use is that if ACES is the standard set of ingredients, then AMF is a recipe. It describes how much of each thing, which things in which order to put them in to view the same image as the person who just viewed it before you. So I think it was Patrick at HPA who said, this is kind of a snapshot of creative intent that can travel along with a shot or be archived. It helps reduce ambiguity for all parties that are receiving files, and it can also serve as that archival element that I mentioned before. So this is a courtesy of Patrick, who's going to be part of the demo after this. And this is kind of what we imagine it might look like for today's workflows of an AMF, starting with a look being developed, maybe getting sent to a DIT on set, traveling through getting applied to dailies, which you'll see from Colorfront, and all the way down to finishing and archiving with what the Academy has defined as the digital source master, which is based on IMF, which we'll also talk a little bit about. So I want to thank all the participants who worked on this spec. It has been published with ACES 1.2. It's available on the ACES GitHub under the documents section. And I want to thank everyone who volunteered their time towards this effort. It was a lot of work, but one thing I want to highlight is that this is really the start of the real work, I think, which, you know, Jay-Z mentioned the implementation part of it is one thing to write a spec, but we really need to work with manufacturers and you know, get this thing rolled out. So with that, I'm going to pass it to Dan, who's going to talk about implementation. Thanks.
Thank you, Chris. So I'm Dan from Marquise Technology. I'm in charge of the business development, and I'm also chairing the AMF implementation group. So this group's mission is really to take the specifications that the architecture group has created and then discuss the challenges when it comes to implementation. Also, we started to work on a AMF toolkit to help implementers to add this fantastic feature in their product. And of course, through this toolkit, we also want to promote the adoption of the ACES metadata in the various workflows. So if we just go through the next slide, which I can't seem to control from here. So Ricardo, can I just ask you to go to the next slide, please? Oh, now it's better. Thank you. Okay, thank you. So the AMF toolkit is basically what we've been working on for the past sessions. And essentially, the toolkit contains test vectors for the primary use cases that Chris has outlined. We also developed recommendations and best practices for ALE, EDL, FCPX workflows, and of course, new things like Open Timeline IO based workflows. The toolkit also contains a fantastic piece of software that our friends from Plumford have created. So that's the AMF util. It basically handles AMF in various ways, but also it allows you to validate the color pipeline using the AMF instructions. And so that is done through reference material that is provided with a toolkit for the input and for the output. And it's essentially your weapon of choice when you want to control what's going on in the color pipeline when it's driven by AMF. And the next topics that we are working on are obviously the inclusion of AMF into the Academy Digital Source Master and a couple of other things. The first part, it's going to be demonstrated here in a few minutes, but obviously more workflows are going to be developed as people start to adopt AMF, and the goal of the group is really to embrace those as well. So right now we already have a bunch of things for you, some takeaways. Obviously the specification that Chris told you about, this one's available. All the XML schema and standard samples are available as well. And the toolkit is also available in 2 different repositories on GitHub, the AMF util, as well as all the test vectors and best practice documents that we have work on and continue to work on, those are also available online. And then meetings and events. So one of the things that the group is doing quite aggressively from the beginning is to have a once a week meeting, usually on Thursdays, on purpose. We really wanted AMF to get started quickly and get to the real stuff very rapidly with implementers. And so we already have some implementations that we'll present today, but we also discussed the implementation status, how far people are in the implementation, also discussing interoperability issues. We also do small exchanges of AMF files between different products, open source or commercial, and see how things go. And also we discuss the workflows, how they are really doing in practice. But of course, we want this group to augment in size, and we need to have more implementers, but also more users to participate and discuss those practical aspects of this specification. So for anyone willing to join, please contact either Ricardo or myself, and you'll be added to the mailing list. Otherwise, all the meetings are announced on ACES Central. They're open to everyone, obviously. And I'm handing over to Jay-Z now for the demonstration of what we have prepared for today. Thank you.
And just in case, Jay-Z might be having a little bit of an audio problem, so it's Annie again, and I'm just gonna hand off over to the folks to do the demo. Patrick?
Yeah, hello everyone. Thank you, Annie. Just sharing my screen here. Where are we here? So, yeah, as Chris pointed out, AMF is a thing that should enable interoperability between systems. By the way, I'm Patrick from Pomford. We are creating on-set software for the camera department for digital imaging and data management, and have been part of the efforts of building or refining the AMF format. So I want to focus on one of the use cases that have been outlined. So this is the workflow if you have live color on set and adjust a digital look there already on the live signal of a camera, and want to bring that look into dailies creation to get the same appearance of the image in the editing process. So that would be a goal that we try to achieve, to hand over that look from our softwares. In that case, that's LiveGrade on the left. And when you're familiar with ACES, you know that there is an IDT to choose. That's the input transform that's specific to a certain camera. The ODT is then the output transform for a certain display. There is a RRT, the rendering transform, that's a standard transform that's in the middle. And then you have the creative look, the CDL, that represent the actual creative look. And you might think you're good when you're like communicating over email or other ways, what to set as IDTs and what to set as ODTs and what the CDL is. And it feels right, but in fact, there could be details that might be a little bit off. And so you can run into situations where you end up with different images. For example, there could be several IDTs for the camera for different color temperatures. The CDL could be applied in different working color spaces. Even the entire pipeline could be in a different version where there might be slightly differences, or different ODTs might sound similar but are not the exact same thing. So, and this is the problem that AMF solves very well, is by handing over the recipe that Chris mentioned, the receiving software knows exactly what building blocks to use to recreate that same pipeline to then, in the end, recreate the same image. And I want to, show you a little bit how that looks in LiveGrade. So LiveGrade is an application used on set. You have several cameras. We simulate 2 cameras here. Unfortunately, we don't have a camera now, and that would be the output of an SDI monitor. So we're switching between 2 different cameras here. And you see below that this is the color controls down here. There's the IDT again, so I can choose from a range of different IDTs here that are open source, available in the GitHub of ACES for vendors, and also ODTs for different displays. On the right side, I see that I choose the ACES 1.2 version, the new one. From that one, I can then later export AMF. And so in the middle, there is a little bit of a creative look going on. I could adjust to lighting situations here, change the look a little bit. And when I store that in my shot library, so let's say this is scene 23, and I add that up here in the shot library, all that information, that look information is stored in a database. And then either from the look that's currently on the signal or stored from previous times, I can say save selected shots and just get that out of the way. Choose that this is the ACES metadata file that I want to create that represents the entire pipeline that has been set here. And if I look now at my window on that side, you see that a few AMF files have been created, and LiveGrade also creates reference still images that give an extra visual reference where it belongs to and how the image should result. And I think that already gave you maybe a brief overview of what can be done in LiveGrade on set directly in the camera. And I want to hand over now to Gary, who will be on the receiving side in the dailies creation process, and will take it from there. Gary, just let me.
Thank you, Patrick.
Yeah.
All right. Hi, I'm Gary from Colorfront. Bill Feitner also joins me. Bill is our CTO and Colorfront wizard. So let me share my screen quickly. What I'm showing you is a standard Colorfront user interface. But what's special about it, that actually I'm at home. You can see on my camera, I'm surrounded by Lego and slime making toolkits. So I'm using the family computer to actually log into a Colorfront system that runs in an AWS cloud. And I'm going to import my footage from an S3 bucket. So we are working on the Lost Lederhosen project. And fortunately, this was created using a cloud-centric workflow. So my EXR files are in this S3 bucket where I import them. So these are camera log color space EXR files straight from the S3 bucket. I'm dropping them on my timeline. And I see a unprocessed log image. Patrick was kind enough to hand over me the AMF files that he created. So I'm going to pick up one AMF file for this particular shot and import it. Now, if I open up my pipeline editor, you can see the color processing elements that are captured in that AMF file. And I asked Bill to join me explaining what are these steps that you see.
Yeah, so, you know, in the past we had CDL exchange, which is just one small subset of what's needed to build this pipeline. So in this case, the CDL node is taking, like there's an IDT that's converting it to ACES AP0 linear, which is the exchange format. And then the CDL node is then applying CDL in this case, an ACES CCT color space. And that was picked up from the AMF file. That's been one of the failures of the CDL in the past, is that we don't know what's before and after, and we don't know what color space it was applied in. So this shows a real world case. So we got ACES in the cloud, and we've got finally meaningful color exchange that can guarantee that everybody sees the same thing by importing that. Go ahead, Gary.
Yeah, I'm importing the other file that Patrick provided for the other shot as well. So this is very similar. If I quickly open my file browser, and I think we haven't showed how these AMF files look from the inside. So if I just quickly open this one, this is an XML file with all the processing steps. So this is the description of the CDL. This is the description of the IDT. This is the RRT ODT. So this is a human readable XML file that captures the creative intent.
Yeah, so you have the RRT, and you've got the color space that the CDL was applied in. And so, yeah, very powerful.
So I'm opening up another AMF file. if I open the node pipeline, you can see instead of the CDL, I imported the CLF in this case. Bill, do you want to explain what this is?
Yeah, so from Patrick's file, and we'll explain that in the next session on the CLF. This is also called, this is a ACES CLF file, which has the look from Patrick that's been saved as a Commonwealth Format, and Gary's bringing that up. You can see the different elements in it, which describe the whole color pipeline. And so this is a fixed transform that can be passed around if you want a fixed transform. And once again, this was called up by the metadata file, which is really great. So in other words, a subset of the metadata file calls the CLF file. Also, we can iterate on top of it. We can add additional CDL on top of it and publish that. So all of this gets stored in the AMF file for subsequent use. And not only is it going downstream, we can make a change here and send out the AMF file back to SET so that they're seeing the changes that we made. So it's really a bidirectional communication, which is part of a modern workflow.
Yeah, exactly. So this CLF file captures a creative look, or you could say a show-off. How exactly these can be created, we will get back to that in the second part of the demo.
Yeah.
Now, with that I can export this as an AMF and pass it over to another system to pick it up. I hand it over to Dan.
Yes, thank you, Gary. So let's share the screen. I hope everyone can see it. So what happens at this stage is that Gary has created a bunch of EXR files in AP0 linear color space. And what we want to do here is show the other aspects of AMF, not just the color aspect, which certainly we can do, but also what the AMF serves as a purpose, where it can be stored, and how do you work with this. So I have those files that were exported by Gary, and I'm just dropping those on the timeline here. And as you can see, I have them here in ACES. And of course, I can either import an AMF file from here or export one for each one of these shots, or things that the group has worked on is how do we export, for example, a whole EDL here. So if we want to export an EDL here, we would select the EDL, and we have here new export. And when we do that, we can also obviously export the ACES metadata attached to the EDL. And this is going to include the actual EDL file, of course, here for each of the shots. But also we have extensions here that reference the actual AMF files for these shots. So this is something that can be done obviously for EDLs, but we can do the same thing for ALEs and a bunch of other file formats as well. And that ensures that people can exchange the editorial information along with the color information with all the benefits of AMF, and of course the CLF if it is referenced as well in the AMF. So now what I want to do is switch back to what we were doing at the beginning. It's basically getting the actual AMF files from Patrick. So I'll just do that here. I'm going to pick those here, and we're going to load here instead of doing this through an automated import through an EDL. So I'm just going to do that manually. So just you can see the process, but of course this should really be done automatically through conforming processes like through EDLs or ALEs. And once we have this here, one thing that we can do is, of course, go and continue to change the looks here if we wanted to. But the purpose of this part of the demo is really to say, okay, I want to archive this material. And the big difference here is that I want to archive the material, but I don't want to bake in the look, because I might want to come back to the original files later on, maybe in 5 years, 10 years, we don't know. And when I do that, I also want to get back the instructions that allowed me to produce the movie when it first got released. So to do that, we'll switch to our export panel here, and we're going to go with the IMF. We're going to select the AMPS ADSM specification here, and we're going to type in some basic information here for the name. Then we will just very rapidly here put some metadata and this movie 2020, and then go to the export panel, and we will render this out. Now, what happens here is that we're not going to bake in the looks. Like I said, we're just going to rewrap the essence into MXF and create a package with it. And once this package is created, I'll rapidly show you what it's looking like. So if I switch to this other folder, I have this IMF package here. And it contains a bunch of files plus the AMF reference files that we were given. So I'm going to load this back into the system here. And I have these assets. As you can see, the assets are stored in linear. They haven't been color correct or anything. But if we switch to compositions here, if I just load this composition, it turns out that I also have the looks being available here, but they are stored as metadata. So for example, if I just open here and double click on this asset, I get access to the original assets that Patrick has created and Gary used later in the process. And what we have done here, we have created an archive and also made these elements being part of the archive. And of course, the most important, made them available when you want to pull the archive back out of your vault. And I think this concludes this rapid demonstration about how AMF can be used in various situations. Of course, if you have any questions, we'll see that in the Q&A session.
Exactly.
Thank you.
Thank you, Dan. This was amazing. I mean, I'm reporting with tears in my eyes here, tears of joy. I wiped them away seconds before. So it was amazing that we already saw the handoff between these 3 different product partners and product supporters here. Asking Scott, are there any questions in our queue?
Yeah, hi. There are a few questions coming in. I've been trying to answer some of them, and some of the other panelists have been responding as well. But one question maybe for Chris and for Dan might be this one. Is there a limit to the number of clips that an AMF can contain? Is it envisaged that the DIT would be producing 1 per clip, roll, or split? Anyone want to take that?
So, yeah, AMF is basically carrying a reference for the clip that it is dealing with. So 1 clip is referenced by AMF. However, several AMFs can reference the same clip. And then obviously it's a question of workflow. But as far as AMF goes, only 1 clip can be referenced. Chris, you want to add something?
I would just add that I think it's up to the person designing the workflow of what that would look like. It's pretty flexible. The same way you could have a single CDL that you're applying to, that's associated with many different shots, maybe a whole camera roll or a whole scene, or a specific look for each shot that you're adjusting on the fly. So it's not really prescriptive in that sense.
Great, thanks. Another question, frequent question from a lot of people, it relates to specific software support for AMFs and in various tools like EXD, and when will it be supported, and is it supported now, and various questions like that. Rather than answer each of those specifically at the moment, I just want to point out that this is very, very early on after the 1.2 release. So the fact that we're even we have these vendors able to demo this so well today is quite impressive, and we appreciate all the support. For specific questions like that, I'm sure we can address those. You know, the various vendors can specifically answer those questions later on. But stay tuned. We're going to keep demoing some stuff later on.
Good. I'm
Sorry to
also
interrupt.
glad.
Excuse
Yeah.
me, just 1 second. Forgot to say tomorrow we have the implementation group. So all of those interested by this question, please join us. We'll answer tomorrow.
Yeah, go to acescentral.com to find our links to the different virtual working groups, acescentral.com. And I'm glad now that the world out there now saw the face of Scott Dyer there, because normally he is the one who answers loads of questions on ACES Central. So it's we are very interactive, open, and public there. And I know it hurts Scott to ask the question to our partners here, because normally he's the one answering the questions. Now I want to go next to our next block there. So we have Doug Walker there describing the CLF to us. Doug, take it away. Nice head.
Thanks, JZ. Yeah, I have my my ACES cap on today because, well, mostly because I'm a fan of ACES, but also a little bit because I haven't had a haircut in about 3 months. So maybe some of you can relate to that as well. But I'm very happy to be with you today on Zoom to talk about the Commonwealth Format. So I'm, as JZ said, I'm the chair of the Commonwealth Format Implementation Working Group. I'm also the technology lead for color science at Autodesk. And I want to start with a quick intro to Commonwealth Format. So the Commonwealth Format is a modern, non-proprietary LUT format that defines a set of standard mathematical building blocks. And it has all of the usual ones like 1D LUTs and 3D LUTs, as well as some new ones that have been added to facilitate working with floating point data. And these building blocks can be stacked together like Legos in an XML file, and you can have as many as you want in whatever order you want. And that makes it possible to define some fairly sophisticated color processing pipelines. Now, you may say, you know, the industry has a bunch of proprietary LUT formats. Do we need another LUT format? And the reason that we do is because we're really thinking about what it takes to become an archival element that could go into an archive with ACES masters and be interpretable years later. And so these are sort of the 4 primary requirements. So of course it's ACES, so it has to be floating point ready on input and output. It needs to be thoroughly documented with a peer-reviewed, published specification. And J.D. Vandenberg from Disney chaired the spec drafting working group, which concluded last year, and that spec is now part of the ACES 1.2 release. Furthermore, we need an implementation test kit so that we can ensure that the implementations from different vendors are all producing the same results. And furthermore, it's very helpful to have a high quality open source implementation. And we're going to talk a little bit more about those last 2 parts. So I'm chairing an implementation working group. We're meeting every 2 weeks, and we have 3 deliverables that we're planning on producing. So first is a set of sample CLF files. Second is a collection of reference images that implementers can use to check their implementations, make sure they're getting the right results. And finally, an implementation guide. So we'd like to have as many people involved in this process as possible. So I encourage you, and would be great if you could get involved. Our next meeting is this coming Tuesday. All of the details are on ACES Central. So please check that out and join us. So I want to talk just briefly about the ACES Look Modification Transform, or LMT, because this is really sort of the connecting point between these 2 standards of AMF and CLF. So the LMT is how an external looklet is referenced from an AMF file. And one of the interesting things about it is that it requires ACES 2065 color space on input and output. And the reason for that is to reduce a problem that many of you have run into, where you're collaborating with other people or other facilities, and you receive a looklet, but you're not sure what color space it's supposed to be applied in. And of course, that's critical to getting reproducible results. So with an LMT, it's always ACES 2065-1. And that means that if you have the sort of looklet that's typically used today that is working in a camera log space, it needs to be packaged accordingly. And so I'm showing an example here of if you had a looklet that was expecting ACES CCT color space, this is how it would be packaged into an LMT. But as I said, it doesn't have to be ACES CCT. It could be log C or S-log or any other typical log color space. So I'm going to do a demo involving OpenCL IO. And if you're not familiar with OpenCL IO, this is the color management system that's used primarily in the visual effects industry. And it's supported by a lot of software. It's part of the Academy Software Foundation. It's free and open source software. It's available on GitHub. And Autodesk has been contributing a lot to its development over recent years. And so I'm going to show, there's a number of interesting command line tools that have recently been added to OpenCL IO. So there's OCIO convert to process an image through a CLF. There's OCIO checklet to check the syntax and evaluate an RGB value. And there's OCIO make CLF, which will convert other LUT formats into CLF. And it will also do what I was just talking about on the previous slide of packaging traditional LUT into an ACES and AMF compliant LMT CLF file. So I'm going to switch over to do a demo, and I know command line demos are not the most exciting thing, so I'm just going to give you a very quick sense of how this works. So down the bottom here, I've got an example CLF file. You can see it's a human readable XML format, and I'm going to run this first command, OCIO checklet. I'm going to pass in my CLF file and an RGB value of 0.5, 0.4, 0.3, and you can see it evaluates that and returns the resulting RGB value. Now, if I edit this CLF and I introduce an error, like I'm going to add an extra value in this matrix here, and I run it again, you'll see that it gives me an error that says, at line 11, expected 3 by 3 and found an extra value. So this is very useful if you have a CLF, you want to validate the syntax of it. It's a good way of doing that. The other thing I'm just going to show you briefly is this OCIO make CLF. So I have here an example CLF file, and it's a traditional .3DL file, and I'm going to create this new mylmt.clf. I'm going to package it as an LMT using the ACES color space conversion or CSC transform ACES CCT. So I'll just run that, and if we look at the result, you'll see these same 3DL values are there now in the XML file, and on either side of it, it's packaged with the components needed to make it a proper LMT that's compatible with AMF. So if I go back to Keynote here, I just want to mention that, so this code it's free, it's available now on GitHub. The link is there. The OCIO make CLF tool is in a PR, but it's all there on GitHub. And if you have any questions about how to compile it or how to use it, just make a post on ACES Central or on the OCIO forum, and we'll be happy to help you. So this This CLF work is part of OpenColor IO v2, which is the new version under development. It's coming soon. We'll have a release, an announcement about that at SIGGRAPH, so I hope you'll keep an eye out for that. And that wraps up my part. So with that, I'd like to turn it over to Bill Feitner and Gary Vass.
Thank you, Doug. So let me share my screen again. So welcome back to ColorFront running in the cloud. So yes, the CLF format is very, very important. From my point of view, with both the main advantages that it provides you both the mathematical precision and the ability to capture a creative look, a creative intent. So as an example, let me import an AMF that exactly does that. So a file with more like a neutral look would look something like this. But let me open another AMF that captures a more stylized look. So this is a more filmic look. So if I show you my pipeline, you can see this is the CLF file that I imported, and this is the effect. Bill, do you want to comment what this CLF does?
Yeah, so this is, I've just briefly going over a few of the questions that have been coming in, but yeah, this allows the basic, ACES path and things we've been showing before have just accommodated CDL values, and you can only go so far as manipulating images. In this case, this is applying specific looks, a whole different augmentation to the ACES workflow. So virtually any augmentation is possible, and it can be wrapped up in a CLF file, and in this case, the AMF file that Gary is loading then references this CLF file, and then this is putting on a custom look. In this case, the custom look was from an AGFA film stock that was, was there because, who knows, you can design within, we'll go into that in just a minute, but you can design pretty much any look with the ColorFront look design tool, and then you can publish it as a compatible CLF file. Yeah, sorry, too many things going on. Yeah, it's a compatible CLF file, and then that can be passed on for anybody to use. So so this is showing the CLF file being used as a creative, as an LMT to augment the ACES pipeline. If you toggle that LMT on and off, you'll just see, yeah, and you can see so you can see the changes, not the best on Zoom, but you can see now, turn it on again. So, it's affecting the overall look and the balance of colors and things that you can't do with the CDL. So it's going beyond. I noticed some things coming in, can we adjust secondaries and things? Well, within this kind of an environment, anything's possible can be put in there. And in fact, this has a very complex set of operations that are going on that's working on the image. I'll let Gary bring up the next set of images, which he'll talk about. Not only is it good for creative changes, it also can be used to solve problems along with creative changes. So here we go with, this is just a raw file, it's, I believe log C, and so now we're bringing up this the stock ACES pipeline on this, and the IDT, you can show what it's doing, and we can see here this has some very, very overblown blues in it that from LED lighting, and we can see that it's all going out of gamut, and we're causing a lot of clipping and things. So one thing that can be done is that we can import another AMF that references an LMT, which is based on a CLF that has the Academy published matrix fix for that. So we can, you can toggle that on and off, and okay. And then we can do much more complex things. So let's load the next AMF, which references a more complex LMT, manifest as a common LUT format, CLF LUT. And we can see what this is doing. This one's more complex, so you see it doesn't affect any other colors in the scene. This is just affecting those wide out of gamut colors and remapping them back in. So that's really good.
Just to explain, so the first CLF that I was referencing, if you look at the file, it's very simple. It's a mathematical matrix operation. It's a pure mathematical solution. When Bill mentioned the other LMT was slightly more complex, that means it's actually a 3D lookup table that captures the ColorFront engine generated look. That also solves the same problem, perhaps in a slightly more sophisticated
way, yeah. And that in there's basic elements, just where, you know, taking the linear light in, putting it into the working color space, doing a logarithmic conversion on it, applying the more complex color mapping and the 3D LUT portion, and then converting backward into ACES linear. So works very well. Here's another case of just applying a look to it. And of course, this is the same AGFA look that was before. The AGFA look goes through the ColorFront engine implementation, except now it's putting a stylized look based on an AGFA film profile on the film. And the reason these work is that what we do with the ColorFront engine part of it is that it's a perceptual processing engine. In other words, we're treating all the colors as our eyes would see them and handling all of the out of gamut colors properly so that nothing gets clipped or thrown away. So it's a lot of complex operations, but this shows the how well the LMT implementation, what it can do, and then with the being able to implement it in the CLF, it works very well. So Gary will show the last part of this. And how do we create them?
I imported the AMF file that has one additional metadata that imported instead of the LUT. It actually recovered all the sliders, all the parameters of that transformation that we exported earlier. So softwares that understand these CFE files can recover the fully parametric LMT. That again we can publish as a CLF, so we can stay true to the ACES idea of being compatible, because we can publish it as a lookup table. But on top of that, we have our own custom LMT generator, our own look generator that produces technically correct and also good-looking images.
So this would, yeah, travel downstream into the ColorFront products, but if it's going, or the ColorFront plugin in other products, or into anybody's product that supports the CLF, because it can be published as a fixed CLF and then go downstream into anybody's product, or upstream, as a matter of fact. So, I mean, Gary can show how you can alter things. You can change different looks. We can put, low con film. We have, there's basically the ARRI K1S1. It's a whole library full of things, blend and match things. And if you're using this, then extreme colors and things, we've done a lot of work on that as far as handling out of gamut colors and things. And if you publish it as, like I said, as an industry compatible CLF file, then anybody can use that.
So yeah, this is our LMT generator module that is part of ExpressDaily's onset dailies transcoder. And yes, ExpressDaily's as well as other products will not only support the EMF, but yes, just like CDS, you will be able to apply this to a single shot, to a whole clip. So it will be, we are really excited about it. It will be a very flexible workflow, and hopefully that will eliminate a lot of the issues of incorrectly named lookup tables and just messed up color pipelines.
Great, thank you all for joining in. I actually did pull my head in front of you. I can put my head back now. So all the vendors helping us to make this, to make ACES and today's webinar a great success. We had Pomford handing over metadata to ColorFront, handing over metadata to Marquis. Doug with Autodesk did show the Frame.io tools. and we did show the integration of the new tools in ACES 1.2. Also want to say thank you to the HPA with the help of the ASC provided the footage we used today. And Scott, do we have more questions in our Q&A slot? Everybody down there in the middle, there is a Q&A bubble where you can write your questions, which Scott will ask.
Yeah, people have been asking questions, and hopefully we've been trying to answer them as best we can. I know a lot of the panelists have been helping me out and replying if they know the answer. So thank you to everyone who's been monitoring that. The question just came in about keyframing in AMF. As far as I know, AMFs do not contain any sort of timeline information or timing information, but it does. There might be ways to use like an there's probably ways to do that, but it's really complicated. So no keyframing or anything like that. It's independent of time. And Dan just answered that, so thanks. And let's see. Will AMF be compatible with OCIO? I don't know if that, let me see, how would that work? Doug?
We'd be happy to accept a pull request to implement that.
There we go. Not at the moment, but it's possible that there might be some sort of integration there later if some ambitious person wants to add that. So,
but the OCIO color transforms can be exported, as Doug said, into a CLF file, and there you have full compatibility in that sense.
Yep.
We also have the loop back procedure in our development process. So we start with an architectural group, go into the implementers group. If there's new features, new requests coming out, we pull it back into the architectural group, but it had not happened yet. So I guess we did a good job there. One of the questions which I did read, are there new IDTs in version 1.2, which is actually a great segue to Alex Forsyth, our ACES staff technology lead, who now will be able to explain to us what else is in ACES 1.2. Hello, Alex.
Hey, everybody. How you doing? All right, let's see here. So as we've been talking about the major features here for ACES 1.2 or the Commonwealth Format specification and the new ACES metadata file specification, but there are a few other additional features that I thought we'd just point out. Number one is that we've rolled into ACES 1.2 this project organization and development procedure document. This basically is our Bible for how we go about developing ACES from sort of an organizational perspective. This document's been available for a little while. There just hasn't been ACES release to roll it into, but we've now formally rolled it into the ACES 1.2 release, and it's version controlled with all our other documents. So if there are any additional changes, you'll be able to track those and see those. Anybody who's interested in that, feel free to download that document, take a look at how we go about developing ACES and what the development procedure is. So with regards to important transforms, we've added a bunch of color space conversion transforms to ACES 1.2. This is mostly to support different color space transforms that are happening in the ACES metadata file, or could be referenced by the ACES metadata file, and to normalize the collection of transforms that are likely to be implemented across various product partners' implementations of ACES. We did make available in ACES 1.2 a set of P3 D65 ODTs for HDR, specifically ST2084. So those are now rolled into ACES 1.2, and we've also added a Sony Venice IDT, much requested Sony Venice IDT. Sony was the one who generated that, and we've just included it into the package, the ACES 1.2 package. There's a bug fix that we added. There was a chromatic adaptation transform that was missing from one of our inverse ODTs. Unlikely to have really bothered anybody, but regardless, we fixed it because it was a problem. And then there were a bunch of miscellaneous changes that you can see here. relatively important one is that there was a bug in CTL with how we used one of our variables or defined one of our variables, and it was causing a problem for one of our product partners. So we made a change to how the ODT parameter is using that variable or is defining that variable. The ACES versioning system is basically the document that defines what transform IDs are. We've extended the transform IDs so that they can, we can allow transform IDs for additional user-defined transforms, and the versioning document was updated to reflect that. And then we appropriately updated all the transform IDs within the reference implementation transforms. We removed the old ACES clip metadata file format specification because that has been superseded now by AMF. And then we just added reference images and made some typo fixes in our source documentation. That's kind of a full list, top to bottom, of all the new features and fixes in ACES 1.2. So back to JZ.
Thank you, Alex. Yeah, so the Q&A is permanently going on ACES Central. I would like to go now straight to what we have learned onto the next slide. And also want to talk about ACES 2 development. So ACES 2, as we know, everybody got and everything got delayed by the situation we are all in globally at the time. So the launch of ACES 2.0, which is actually a big effort, we have a Gamut architectural study group going on at the moment. We have an IDT implementation group coming up soon. Thank you, Josh Pines, for leading that one. Other groups are forming. I just got a text from the ASC as well. They put on the quick starting guide for DPs, for cinematographers, onto their ASC webpage. So there are links to product partners and supporting groups, virtual working groups, talk to each other and form each other, documented via ACES Central. So everybody who is interested can join such groups, give input in either the architectural part or in the implementation part later. Again, and also ACES Central will get a new phase. So watch out. It's I think it was planned for the end of this week or beginning of next week that we're gonna have a new face on ACES Central, new look and feel. And thank you to all the product partners who supported us today. Doug or Scott, is there any important Q&A question we cannot live without answering right here, right now?
Super important. I mean, I think all questions are important. I want people to get the information they want, but we won't address, I don't think anything that's still open at the moment. As JZ said, the place to ask questions, anybody can ask questions at acescentral.com. It's a great community of people, including all the vendors and people involved in the development of these specifications and the implementation of these specifications. So, and you can be involved too, as we've mentioned. So go there and ask your questions if you've got follow-ups. And yes, I will answer one more time. We are recording this and we will post it for you.
Exactly. We will also post a recording of this webinar. The PowerPoint presentation will be posted. So please sign up with ACES Central. Keep an eye on ACES Central, and see you next time. Stay healthy, everybody, and looking forward to see you testing ACES 2.0 with us. Thank you all for joining in.